Hi students, here I am to discuss about a few textual questions from coordination chemistry. The first question is titanium H2O 6 times 3 plus complex ion is colored while scandium H2O 6 times 3 plus is colorless. That is hexa aqua titanium 3 plus ion is colored. Hexa aqua scandium 3 plus ion is colorless. Explain. See, titanium, here it exists in 3 plus oxidation state because water is a neutral ligand. The total charge carried by the complex is the charge corresponding to the titanium metal. Similarly, scandium also exists in 3 plus state only. Water is again a neutral ligand. So both titanium and scandium exist in 3 plus oxidation state in the given complexes. So that can be the sentence over here. Scandium, the configuration, actual configuration of the atom scandium is outermost electronic configuration is 3d1 4s2. After losing the 3 electrons, it takes up 3 plus oxidation state, which is 3d0 4s0 again. Titanium, the element has the outermost electronic configuration 3d2 4s2. After losing 3 electrons, it gets the configuration 3d1. So what is the difference between scandium 3 plus ion and titanium 3 plus ion? Scandium 3 plus ion does not have any electron in the d orbital, whereas titanium 3 plus ion have one electron in the d orbital. Whenever the complexes are colored, the reason is that the electron in the d orbital absorbs energy and in the region of light, and it is excited to a higher energy level, and this particular region of light, that is the visible region of light which is absorbed, the complementary color will be exerted by the particular complex. That is the theory. So here titanium 3 plus ion has one unpaired electron 3d orbital. So it undergoes dd transition, that is it absorbs light and the electron jumps into another d orbital, that is called dd transition. And this promotion to higher energy level by light absorption is not possible in the case of scandium because it does not have any d electron. So there is no dd transition that is taking place in scandium 3 plus ion. So no light absorbance, hence scandium 3 plus ion containing compounds are colorless. The next question is, arrange the following in order of increasing molar conductivity. First you must know, before going into the complexes in detail, first you must know what is molar conductivity. See, when you take the solutions in terms of molar concentration, the solutions, provided the solutions are all electrolytes. Electrolytes meaning when the current is supplied, the solutions conduct current, conduct electricity. How? Because the electrolytes dissociate into positive and negative ions. So that is called as molar conductivity of the electrolyte. This molar conductivity of the electrolyte depends upon the number of ions which is generated by the electrolyte and also upon the charge carried by the ions. Depends upon the number of ions generated by the electrolyte and also the charge carried by the ions. Here are given 3 complexes. The first complex is a simple cation magnesium and the complex anion CrNH3Cl 5 times. The second complex, both cation is also a complex, anion is also a complex. First complex has one simple cation and one complex anion. The second complex can furnish 3 complex cations and 2 complex anions. The third complex is a neutral complex. So it does not dissociate into ions. So conductivity is not possible for the third complex solution. So when you compare the first complex, it dissociates into Mg2 plus and 1 CrNH3Cl5 2 minus. And second complex dissociates into 3 CrNH3Cl2 plus and 2 COF6 3 minus ions. Okay, third complex will not dissociate. So the number of ions as well as the charge carried by the ion is greater in the case of the second complex. Second complex altogether furnishes 5 ions, 3 cation and 2 anions, and the charge carried by them is also greater. Hence, the second complex has greatest molar conductivity. So when you increase it in the increasing order of molar conductivity, you get the neutral complex first, which has 0 molar conductivity, and next the magnesium complex, and next the second complex. So that is the answer. If this question is asked in 2 marks, you need not give the explanation, you just write the order. It is enough. If it is asked in 3 marks, you have to give the explanation. Why tetrahedral complexes do not exhibit geometrical isomerism? See, geometrical isomerism is also termed as cis-trans isomerism. This particular isomerism, when the similar groups takes up adjacent position, it is a cis isomer. When the similar groups attached to the central metal atom takes up opposite positions, it is a trans isomer. But in the case of tetrahedral complexes, there is no opposite positions. All the positions are adjacent positions only. So they are adjacent to each other. There is no opposite position. So all the 4 ligands are adjacent or equidistant to one another. So the relative positions of donor atoms of ligands attached to the central metal atom are same with respect to each other. So there will not be any cis or trans position to exhibit geometrical isomerism. So that is the reason why tetrahedral complexes exhibit geometrical isomerism. You may have a question, which complexes exhibit geometrical isomerism? Octahedral complexes and square planar complexes exhibit geometrical isomerism. Let us move on to the next question. A solution of NiH2O 6 times 2 plus is green, whereas a solution of NiCN4 2 minus is colorless. When you calculate the oxidation state of nickel in both the complexes, the first complex, hexa-aqua complex also, nickel exists in 2 plus oxidation state. Tetracyanido complex also, it exists in 2 plus oxidation state. The 2 plus oxidation state of nickel is 3D8 configuration. 3D8, 4 is 0. And 3D8 configuration, when you draw the box diagram, you will find there will be 2 unpaired electrons. And these 2 unpaired electrons remain unpaired, okay, when water is the ligand in the hexa-aqua complex, because water is aqua is a weak ligand. So the DD transition is possible. It absorbs red light, and so only that hexa-aqua nickel complex is green in color. The complementary color is given, is imported by the complex. But when in the case of tetracyanido nickel 2 minus complex, the cyanide ligand is a strong ligand, so it pushes the unpaired electron for pairing, so there will not be any possibility of DD transition. There is no unpaired electron. Here it is given impaired, it is wrong, I have corrected there, just see that it is unpaired electron. So 3D orbitals pair up, there is no unpaired electron, so it is colorless. So that is the reason. So we'll move on to the next question. What is coordination number? What is the coordination number of atoms in BCC, body centered cubic unit cell? What is coordination number? The number of closest neighbors, okay, and a central atom can hold is called as coordination number. In a particular complex is called as coordination number. The body-centered cubic unit cell, as you see in the picture, the body-centered atom experiences or the neighbors are present on 8 corners. So the coordination number is 8. Each corner atom will be surrounded by 8 atoms. Again, the coordination number is 8:8 for body-centered cubic unit cell. Thank you, children. Hope you've understood the questions discussed. I'll meet you in the next class.